Good morning to everybody. So we will start today chemistry of lipid. Now so far we have learned chemistry of carbohydrate, those macromolecules, no? Chemistry of carbohydrate, chemistry of protein. Now the next important macromolecule is lipid. Lipid, this we will discuss according to this introduction, definition, function, classification. Then these are the some important lipids we will discuss in brief. So lipid, this word comes from the Greek word lipos, means fat. So all of us, we know what is fat, no? We have touched oil, that is the feeling of lipid. Then butter we have touched, that is the feeling of lipid. Okay. Now lipids, they are the heterogeneous compound. In carbohydrate, we have seen that polysaccharides are made up of multiple monosaccharide units. These are the polymers. Okay. In protein, we have seen polypeptides are nothing but the polymers of amino acids. But lipid is not such type. There is no unit by combination of which a series of polymers are produced and that called lipid. It is not like that. It is rather a small molecule. A small molecule. It is different from carbohydrate and protein. 1 gram of carbohydrate, when it is oxidized, gives 4 kilocalorie of energy. Okay? 1 gram of protein, when it is oxidized, it gives 4 kilocalorie of energy. That means carbohydrate and protein gives equal amount of energy, but a lipid, it gives 9 kilocalorie of energy. So this lipid is preferred as the energy store on the body. A male person stores about 20% of his body weight as lipid, and females, they store about 25% of the body weight. So that's why they are the chief storage form of energy beside their role in cellular structure and biochemical function. We have seen there are phospholipids in the cellular membrane. So in cell membrane structure, other part of the cell structure, mitochondrial membrane structure, these lipids are the important molecules that take part. Other than other biochemical function also, they perform, such as steroid hormones. They are the lipids only. Okay, we will know after a few minutes. So definition, lipids may be regarded as organic substance relatively insoluble in water. Oil is not soluble, butter is not soluble. Okay, so it is relatively insoluble in water, but soluble in organic solvents, actually or potentially related to fatty acid and utilized by the living cell. Definition that will be asked in your viva. Wherever there is a short note, you have to write the definition. So memorize this definition, not long, not difficult to remember. Okay? Now coming to the function of the lipid, it is stored in the adipose tissue where it is also served as the thermal insulator in subcutaneous tissue. Lipid is bad conductor of heat and electricity. Okay? So our subcutaneous tissue, in subcutaneous tissue there is deposition of fat as triacyl glycerol in the adipose tissue. That provides insulation of the body to prevent core temperature to dissipate. That means body temperature is maintained. It gives shape to the body. Okay? And it is the main storage of energy. The amount which is stored in the body is sufficient to give 2 to 3 months energy supply in the body. Energy or food reservoir is stored as triacyl glycerol. The fat which is stored in the subcutaneous tissue is nothing but the triacyl glycerol. Previously it was told as triglyceride. Now it is called triacyl glycerol. So structural component you know already. We'll proceed next. Important cellular metabolic regulators, prostaglandins, steroid hormones. So when you come to the respective chapters, you will know how important they are. Hormones. Lipid compound is inner mitochondrial membrane and participate in electron transport chain. By this time you know what is electron transport chain, and lipid plays a very important role in electron transport chain. Classification broadly classified as 4 classes. Simple lipid, complex lipid, derived lipid and miscellaneous. In some book they say neutral lipid again. So if you write 4 classes, that will give you full mark. But if you mention 5, that also doesn't matter. Okay. Now simple lipids, these are the esters of fatty acid with glycerol. So if we take this is a glycerol, here one fatty acid is attached, here one fatty acid is attached, here one fatty acid is attached. So fatty acid 1, fatty acid 2, fatty acid 3. Okay. So they are the esters of fatty acid with glycerol. Mainly 2 types, fats and oils. Difference between fats and oil are: fat is solid in state in room temperature, oil is liquid in state. Only this physical difference is there. Otherwise, they are same. Waxes, esters of fatty acid with alcohol other than glycerol. In wax, glycerol is not there. Okay? So the alcohol which is present in wax is cetyl alcohol. Cetyl alcohol. Okay? In wax it is present as cetyl alcohol. This you have to remember. Complex lipid, these are the esters of fatty acid plus alcohol. In addition to that, other groups like phosphate will be there, nitrogenous base may be there, carbohydrates may be there, proteins may be there. Based on the group present, they are further classified into phospholipid. In phospholipids, there is fatty acid with alcohol plus phosphoric acid as nitrogenous base. Based on the types of alcohol present in the compound lipid, they are classified again broadly: glycerophospholipid, sphingophospholipid. In glycerophospholipid, glycerol as alcohol is there. Example given: lecithin and cephalin. In sphingophospholipid, alcohol is sphingosine. Example is sphingomyelin. It is present in the nerve tissue. Okay? It is present in the nerve tissue in the myelin sheath. So name itself suggests where it is present. Sphingomyelin. In glycolipid, the second class of complex lipid is glycolipid. Here, along with the fatty acid and alcohol, carbohydrates and nitrogenous base may be present. They contain sphingosine as alcohol and hence known as glycosphingolipids. Glycosphingolipids. Example are cerebrosides, gangliosides. Lipoproteins. These are again very important. Lipoproteins. They contain, instead of carbohydrate, they will contain protein part. Okay. So these are macromolecular complex with lipid with protein. VL, example is LDL, low density lipoprotein. VLDL, very low density lipoprotein. Chylomicrons. Then HDL, high density lipoprotein. High density lipoprotein is considered as good cholesterol because it decreases the LDL, VLDL. LDL and VLDL, they are responsible for atherosclerosis, damage of the blood vessels, especially when it is in the coronary artery that produces blocks and causes myocardial infarction. Okay. Now this HDL, it reduces both the offending, this VLDL, LDL, cholesterol, it reduces those and reduces the possibility of atherosclerosis in the coronary artery. Now in cell membrane you have seen so many glycolipids will be there. Then phospholipids, you know, lipid bilayer membrane, phospholipids are there. And other complex lipids are sulfolipid, aminolipids and other lipopolysaccharide comes under this group. Okay. Derived lipid. These are nothing but when complex lipid is hydrolyzed or some other complex compound lipid is hydrolyzed, these are the products. So these are derivative hydrolysis of simple and complex lipid which possess the characteristics of lipid, like lipid soluble vitamins, steroid hormones, hydrocarbons, ketone bodies, beta hydroxybutyric acid. Okay. Then mono and diacyl glycerol. I have told you this is glycerol. So when derived protein, no? When it is hydrolyzed, say this is hydrolyzed. So how many fatty acids are there? 2. Now it is called diacylglycerol. Okay. Now once again it is hydrolyzed, the second one. So only one is left. Then it is called monoacylglycerol. That is the thing said here. Okay. Now derived lipid, when simple lipids and compound lipids they are hydrolyzed, the product, they are also having the same characteristics of lipid, and then it is called derived lipid. Neutral lipids, they are having no charge. No charge, actually they are mentioned, but if you don't mention so it doesn't matter, because triacyl glycerol, cholesterol, cholesterol esters, they comes under these compound lipids also. So this one, they do not have charge, uncharged. These are the lipids which are uncharged and are referred to as neutral lipids. These are mono, di and triacyl glycerol, cholesterol, cholesterol ester. Miscellaneous lipids. A large number of compounds possesses characteristics of lipid. Such compounds come under this category. Carotenoids, precursor of vitamin A. Squalene, hydrocarbons, then pentacosome. Then pentacosome, this is present in beeswax, beeswax. Then turpentine oil, terpene. Okay, these are also comes under this miscellaneous group. So, when classification is said, you give the classification, give an example where it is feasible, where it is there, and write that much only. Now, next important thing is fatty acid. Very important. It is the simplest form of lipid. Usually contains even number of atoms. When you read biosynthesis of fatty acid, you will see that each time 2 carbon atoms are added in the fatty acid chain. So it comes 4, 2, 4, 6, 8 like that. But it is not only that, only even number carbon atoms are there. Some uneven number carbon atom containing fatty acids are also there in the nature. This is 6 carbon fatty acid. Okay? Now, you can see there is no double bond in this fatty acid. Okay? So, this type of fatty acids are called saturated fatty acid when there is no double bond. When there is one or more double bond present in the fatty acid chain, then they are called unsaturated fatty acid. So here one double bond is there. This is called unsaturated fatty acid. Because it contains only one double bond, we will call it as monounsaturated fatty acid. If it is containing more than one double bond, we will call it as polyunsaturated fatty acid, not diunsaturated. Okay, only 2 are there. Either it will be monounsaturated or polyunsaturated. Usually, fatty acids are found in esterified form, but they are found as free form also. Okay, free fatty acid. But those free fatty acid, they very shortly they get esterified. Fats of animal origin are more simple than that of the plant origin. Example are palmitic acid, stearic acid. They are the carboxylic acid. The carboxyl group is there, so they are called carboxylic acid with hydrocarbon side chain. Essential fatty acids. Some of the fatty acids are essential fatty acids, some are non-essential fatty acids. We have learned in the protein chemistry there are essential amino acids. Sorry. In lipid fatty acid also there are non-essential fatty acid and essential fatty acid. Essential fatty acids are linoleic acid, linolenic acid. These two are the main essential fatty acid. But third one, arachidonic acid, it becomes essential when the precursor linoleic acid are not adequately supplied in the body, not adequately present in the body. So, this arachidonic acid cannot be synthesized in the body in that situation and it becomes essential. Now, why these are essential? Because human being doesn't have the enzyme which introduce double bond beyond 9th carbon. Okay? Up to 9th carbon, it can introduce double bond in our body. But after that, the enzyme which is required to introduce double bond is not present in human body. So, they cannot be produced in the body and needed to be supplied from the outside. Fatty acids can be synthesized by the body and therefore has to be essential fatty acids cannot be synthesized by the body and therefore has to be supplied in the diet. Functions: membrane structure and function, transportation of cholesterol, formation of lipoprotein, prevention of fatty liver. They help in transporting fat from the liver to the other part of the body. So, liver doesn't get deposited excessive amount of fat which cause fatty liver. Fatty liver, what happens if there is fatty liver? Ultimately, it causes cirrhosis of liver. Liver damage is there, cellular damage is there, so there will be cirrhosis. Now, a bit detail I will tell afterwards. Disorder due to deficiency of essential fatty acids. This is called phrenoderma or toad skin. There is presence of horny eruptions on the posterior and lateral part of the limbs, on the back and buttocks. There is loss of hair and poor wound healing. Okay, you might have seen somebody's this external part of the limb, it becomes rough, no? Horny type. If you touch, you will find this one. Then these buttocks also, these things will be rough. What you call? These pinhead-like eruptions are there. Okay, this is because of essential fatty acid, deficiency of essential fatty acid. Now, we will now see how fatty acids are, carbons are numbered. Now, they are numbered in two ways. One is 1, 2, 3. Next is omega. You have heard of omega-3 fatty acid, omega-6 fatty acids, omega-9 fatty acid, you might have heard. Okay, now, number of carbon of carboxyl group is termed as 1. After that, following that, this is the 2, 3, 4, 5, 6 and so on. It may be up to 24. Okay. Now, another system is, this is one system. Another system is, we call this carbon of methyl group as omega-1 carbon. Omega-1. Can you see? Visible? Yes. This is omega-1. So it comes omega-2, omega-3, omega-4, omega-5, omega-6. Okay. Now, this is a 6 carbon fatty acid. Now, if it is 24 carbon fatty acid, how you will write the formulation? It will be this much long. No? So, scientists, they have developed a system where this type of long chain fatty acids or all fatty acids are denoted. Here are some. Just see this. Say this one. This is a 24 carbon fatty acid. Okay. In that case, how they write? First they write number of carbons. So here 6. I will write here 6. Okay. After that, they write number of double bond. Here it is 1. Okay. Now the carbon position where double bond is present. Here it is 2 and 3. So they will write 2. Now this is a fatty acid containing 6 carbon chain having only one double bond between carbon 2 and 3. Now, if there is no double bond, then it becomes zero. Okay, this is the thing shown here. See, this 24 number carbon atom, this 24 number this fatty acid having 24 number of carbons having no double bond. So they will write like that. But usually this systemic name is used. Say ethanoic acid, propanoic acid, butanoic acid. Okay, like that. This is the nomenclature we commonly use, but this is the abbreviation what is used. Now this is the unsaturated fatty acid, palmitic acid. It has 16 carbon having one double bond at 9 and 10 position. This is arachidonic acid, 20 carbon having 4 double bond in 5, carbon number 5, 6, 8, 9, 11, 12 and 14. I told arachidonic acid, it becomes essential when there is inadequate supply of linoleic acid, because after 8 up to 9 we can introduce double bond, but 11 and 14 we cannot. That's why it becomes essential. And linoleic acid, after 9 we cannot. Here 12 is there, so for that, and that enzyme is required. Here 12 and 15 is there. We need that enzyme. to introduce double bond, but we don't have that enzyme. That's why we have to supply it from outside. The next important lipid is triacyl glycerol. I told you plenty of triacyl glycerols are there in our body. Okay, this is also called previously as triglyceride. Esters of fatty acid and glycerol widely distributed in the body, insoluble in water. It is non-polar, hence known as neutral fat. Serve as fuel reserve sufficient for 2 to 3 months. They do not serve as structural component of the cell. You will know, you will be surprised to know that, see, in adipose tissue, a lot of triacyl glycerol is deposited. Okay, it is kept deposited inside the cytoplasm as droplets. Okay, it is so much deposited that the total cytoplasm, it is pushed in the periphery, including the nucleus. This is nucleus, and the whole is triacyl glycerol. But it doesn't take part in the structural, it is not a structural component of the cell membrane. It is again divided into two types, triacyl glycerol. With glycerol there are 3 fatty acids. If all 3 are the same fatty acid, this is called simple triacyl glycerol. But these 3, if they are different type of fatty acids, one is fatty acid A, another is fatty acid B, another is fatty acid C, then it is called mixed triacyl glycerol. Mixed fatty acid, that's why it is called mixed triacyl glycerol. Now, there are some properties of triacyl glycerols. They are hydrolyzed by lipases. Okay. Saponification, it is the hydrolysis of the triacyl glycerol by alkali to produce glycerol and soap. The soap which we use is produced by that method only. Okay? The fat is hydrolyzed by the alkali, so soap is produced. Rancidity. This is the deterioration of fat by exposure to air, moisture, light, or bacterial action. Especially unsaturated fats are more susceptible. We know there are many oils in the market containing polyunsaturated fatty acid, sunflower oil, soybean oil. Okay. So these unsaturated oils containing unsaturated fatty acid, they are more susceptible for oxidation of the double bond. Means they are more susceptible for rancidity. To prevent that, antioxidant is added in that oil. Antioxidant prevents rancidity. Antioxidant, what are those antioxidants? Tocopherol, vitamin E. Okay, tocopherol, hydroquinone, gallic acid are the some antioxidant added to prevent the rancidity in commercially preparation of fat and oil. Even in butter also they add. Test to check the purity of triacylglycerol. Iodine number. Iodine number is the number of gram of iodine required, number of gram of the iodine which is absorbed by the 1 gram of triacylglycerol. Now, before this, I want to say one thing. In fatty acid, again, it can be classified as fatty acid. This also you remember, huh? Short chain fatty acid. Medium chain fatty acid, long chain fatty acid, short chain fatty acid up to 6 carbon, up to 6 carbon, medium chain fatty acid 8 to 10 carbon. Long chain fatty acid above 10 carbon. So sometimes while reading you may come across short chain fatty acid, medium chain fatty acid and long chain fatty acid. Milk, the milk contains lipids having medium chain fatty acid. Okay? Long chain fatty acid containing lipids are solid and they are not termed as good fat for the body. Now, iodine number, coming to the iodine number, it is 1 gram of iodine absorbed by the 100 gram of fat, not 1 gram, 100 gram of fat. Okay? Coconut oil has a iodine number of 7 to 10. Remember, 7 to 10, not unit, there is no unit. I told it is the number of gram of iodine. So it is, you will use by only the number 7 to 10. Okay? This is used to know the relative unsaturation of the fat and is directly proportional. The more is iodine number, the more is unsaturated fat content of that particular oil. Okay. Now, next is saponification number. Number of milligram of potassium hydroxide. Previously was gram of iodine required to absorbed by 100 gram of fat. Here in saponification number, milligram of potassium hydroxide required to hydrolyze 1 gram of fat or oil. 1 gram is very small amount, no? So potassium hydroxide will come as milligram. We will take the number only. So it is used to measure the average molecular size of the fatty acid. Value is higher in short chain fatty acid. If short chain fatty acids are more in content, then its value goes high. Human fat having saponification number of 195 to 200. Coconut oil has saponification number of 250 to 260. Richard methyl number. Sometimes you will get Richard methyl number as short note. So number of 0.1 normal potassium hydroxide. We will use the number only. So number of 0.1 normal potassium hydroxide required to completely neutralize the soluble volatile fatty acid distilled from 5 gram of fat. (0.1 normal potassium hydroxide required to completely neutralize the soluble volatile fatty acid distilled from 5 gram of fat. Okay, so it is used to take purity of the butter. To check the purity of the butter, this number is utilized. Some of the volatile fatty acids are butyric acid, caproic acid, caprylic acid. Volatile fatty acids. So also there is another acid number. This is the number of milligram of potassium hydroxide required to completely neutralize free fatty acid in 1 gram of fat or oil. This is also called acid number. Now next important is phospholipid. You will definitely get question from phospholipid. Very important. Now here you have to know the definition of phospholipid, classification and its function. That's all. You will remember this thing, this much only. So as you know, they are the esters of fatty acid with glycerol containing phosphate groups. Okay. Now, depending on the groups, they are classified as glycerophospholipids, which again contain classified as phosphatidic acid. This is the simplest form of all phospholipids. Does not occur in good concentration. Next is lecithins. It contains phosphatidic acid and choline as nitrogenous base. It is the storage form of the body's choline. Choline is stored as lecithin. একটু পরে। Then dipalmitoyl choline. This is the lung surfactant found in the lung, important surface active agent preventing adhesion of the inner surface of the lung due to surface tension. There are alveoli are there. These are the thin membrane sac only. So anytime this may collapse, if there is collapse, there will not be gaseous exchange. So this compound, they prevent collapsing of the alveolus. Lysolecithin formed by the removal of fatty acids from carbon 1 and carbon 2 of lecithin. Then cephalins, phosphatidic acid plus ethanolamine as nitrogenous base. Phosphatidyl inositol present in cell membrane cleaves to form inositol phosphate and diacyl glycerol. These act as secondary messenger when you come to learn the signal transmission in the steroid hormone mechanism of action. Then you will know these functions as secondary transmission transmitter. So also phosphatidyl serine, phosphatidyl threonine, these also act as secondary messenger of the cell. They are important for hormone like oxytocin, vasopressin, etc. For all steroid hormones, there is not a single transmitter. For every hormone, there is a different neurotransmitters are there, signal transmitters are there. Spasminogens, their esterification of fatty acid with carbon 1 with the glycerol forms plasmalogen. Present in adequate quantity in the brain and muscle. Cardiolipins, from name itself, it is we can imagine that they are found in the cardiac muscles. It is structurally 2 phosphatidic molecules are held by the glycerol. Present in the inner mitochondrial membrane and believed to have function in the electron transport chain. The next group is sphingomyelins. They contain amino alcohol, sphingosine. It attaches to an amide group of fatty acid to form ceramide. Sphingomyelins are important constituents of the brain and nerve tissue. Functions of phospholipid, structural components of the cell membrane, takes part in electron transport chain. It helps in absorption of fat from the intestinal tract. Synthesis of lipoproteins and transportation of fat. In synthesis of lipoprotein, they help. Prevents fatty acid by mobilizing the fat from the liver. Eicosanoid production. In eicosanoid production also they help. Okay. Now, what are the eicosanoid that you will come to know during the lipid metabolism? Surfactant. Just now we have told reverse cholesterol transport. So, in reverse cholesterol transport, it helps to reduce the cholesterol in the affected organ, affected tissue. Next is glycolipids. Alcohol is sphingosine and it is esterified with fatty acid. important constituents of the cell membrane. Glycolipids are there. Then cerebrocytes are the simplest form of glycolipids. Gangliosides are more complex form of glycolipids. Cerebrocytes, gangliosides are composed of cerebrocyte plus N-acetylneuramic acid found in ganglion. Here sometimes you will see in the this one hand or feet, in the muscle tendon is there, no? In tendon you will see a round oval like swelling. If you press, it will be hard to soft. You can feel that there is fluid inside. Those fluids are nothing but the cerebrocytes. Now next comes lipoproteins. This is very important. We are very much concerned about lipoproteins. Lipoproteins are injurious to health except HDL. So we will have a separate chapter for lipoprotein metabolism. They are formed by the combination of lipid and protein. There are 5 types of lipoproteins: low density lipoprotein, VLDL, HDL, chylomicrons and free fatty acid. Chylomicrons are intestinal fat globules when they are carried as it is through the thoracic duct. They are called chylomicrons. Okay. Steroids. Steroids compound containing cyclic steroid nucleus. The nucleus is called very big name. Memorize it, you will be asked. Don't remember CPP. CPPP, don't remember that one. Remember the long one. Okay? This is the cyclopentano or hydrophenanthrin ring, the steroid nucleus. It is there in book. You can look up from the book also. Several steroids in the biological system like cholesterol, bile acid, vitamin D, sex hormone, adrenocortical hormone, cardiac glycosides and alkaloids. Steroids as such, they will not ask any short note, but ring, name of the ring, they will ask you in the short note, in the this one, multiple choice question. They will ask you. Now, coming to the next offending agent, important, not only offending agent, if I say offending agent, that will be insult to the cholesterol. Cholesterol is very important also for the body function. Different type of steroid hormones are synthesized from the cholesterol only. Okay, but at the same time, it is a very dangerous molecule. It is responsible for this one, atherosclerosis also. It is precursor of a large number of quality, equally important steroids. So, see, these are very important things. They are synthesized from the cholesterol. Okay? Function is present in the nervous tissue. Cholesterol, you will get short note. Cholesterol, you will get short note. It is present in the nervous tissue insulating cover. Biochemical function it is precursor for many biochemical substances and components of the cell membrane. In cell membrane, if there is more cholesterol, cell membrane becomes more stiff. We don't want a stiff cell membrane. Okay. In cell membrane, we want more fluidity. More fluidity. How this more fluidity is brought? So this is a fatty acid chain. This is hydrophilic and this is hydrophobic. Okay. Now, if there is a double bond, if suppose there is a double bond, then this will have a kink like that. Sorry. So it will have a kink. If it has a 4 double bond, it will just become like a U shape. Okay? Like that. So if there is U shape, yeah. If there is U shape, less number will be, phospholipid will be packed. So fluidity will be more. That's why in cell membrane we want more unsaturated fatty acid to be there. Saturated fat, you know, there is no double bond. There is chemical, they are saturated with hydrogen atoms. Because of their chemical structure, they have a solid consistency at room temperature. Saturated fats can be found in a variety of foods, including animal meat, including beef, poultry, pork, certain plant oils such as palm kernel, coconut oil. If there is the oil which contains more saturated fat will become solidified in the winter in low temperature, okay, or it will be solid in room temperature. So dairy products are also there. So this part we will discuss later on in the next class. Okay. Today we will conclude here. 1 gram of iodine absorbed by the 100 gram of fat, not 1 gram, 100 gram of fat. Okay. Coconut oil has a iodine number of 7 to 10. Remember, 7 to 10, not unit. There is no unit. I told it is the number of gram of iodine. So it is, you will use by only the number 7 to 10. Okay. This is used to know the relative unsaturation of the fat and is directly proportional. The more is iodine number, the more is unsaturated fat content of that particular oil. Okay. Now, next is saponification number. Number of milligram of potassium hydroxide. Previously was gram of iodine required to absorbed by 100 gram of fat. Here in saponification number, milligram of potassium hydroxide required to hydrolyze 1 gram of fat or oil. 1 gram is very small amount, no? So potassium hydroxide will come as milligram. we will take the number only. So it is used to measure the average molecular size of the fatty acid. Value is higher in short chain fatty acid. If short chain fatty acids are more in content, then its value goes high. Human fat having saponification number of 195 to 200. Coconut oil has saponification number of 250 to 260. Richard Meisel number. Sometimes you will get a Richard Meisel number as short note. So number of 0.1 normal potassium hydroxide. We will use the number only. So number of 0.1 normal potassium hydroxide required to completely neutralize the soluble volatile fatty acid distilled from 5 gram of fat. .1 normal potassium hydroxide required to completely neutralize the soluble volatile fatty acid distilled from 5 gram of fat. Okay, so it is used to take purity of the butter. To check the purity of the butter, this number is utilized. Some of the volatile fatty acids are butyric acid, caproic acid, caprylic acid. Volatile fatty acids. So also there is another acid number. This is the number of milligram of potassium hydroxide required to completely neutralize free fatty acid in 1 gram of fat or oil. This is also called acid number. Now next important is phospholipid. You will definitely get question from phospholipid. Very important. Now here you have to know the definition of phospholipid, classification and its function. That's all. You will remember this thing, this much only. So as you know, they are the esters of fatty acid with glycerol containing phosphate groups. Okay. Now depending on the groups, they are classified as glycerophospholipids, which again contain classified as phosphatidic acid. This is the simplest form of all phospholipids. Does not occur in good concentration. Next is lecithins. It contains phosphatidic acid and choline as nitrogenous base. It is the storage form of the body's choline. Choline is stored as lecithin. একটু পরে then dipalmitoyl choline. This is the lung surfactant found in the lung, important surface active agent preventing adhesion of the inner surface of the lung due to surface tension. There are alveoli are there. These are the thin membrane sac only. So anytime this may collapse, if there is collapse, there will not be gaseous exchange. So this compound, they prevent collapsing of the alveolus. Lysolecithin formed by the removal of fatty acids from carbon 1 and carbon 2 of lecithin. Then cephalins, phosphatidic acid plus ethanolamine as nitrogenous base. Phosphatidyl inositol present in cell membrane cleaves to form inositol phosphate and diacyl glycerol. These act as secondary messenger when you come to learn the signal transmission in the steroid hormone mechanism of action. Then you will know these functions as secondary transmission transmitter. So also phosphatidyl serine, phosphatidyl threonine. These also act as secondary messenger of the cell.